All right, so the next section, we're kind of going to take a timeout from Unit 4 because I'm realizing as we're doing more of this work and these problems that you have some Pythagorean theorems coming up and some more radicals that we're going to be working with. So now is a good time to kind of go through simplifying radicals and Pythagorean theorem. I hope that this is review for you guys, but let's go ahead and get into this. So simplifying your radical. So I kind of went over this quickly the other day, but I didn't expect you to know it for your quiz. So from now on, you do need to know how to simplify your radicals, okay? So for number 1, I'm going to go ahead and take my 80, and I'm going to find any two numbers that multiply to equal 80. There's more than one solution. You use 8 times 10. I'm going to use 2 times 40, and you could do lots, 4 times 20. You're going to look at your numbers that you have left, and if they're prime, then you're going to stop. So 2 is a prime number. I'm not going to write anything for that. But for 40, I can go a little bit further, and I can do something like 4 times 10. I'm going to look at these numbers again and see any two numbers that multiply to equal 4, which would be 2 and 2, and any two numbers that multiply to equal 10, 2 and 5. And you can cross out. Sometimes I see students using those numbers that they've already broken down again. So sometimes it's helpful to go ahead and X them out so that you have less numbers to look at. The idea is this is called a square root. It gets its name from the square. When I say x squared is represented as x to the 2 power, right? So square always emphasizes a 2. There's actually a 2 that's here, but they never write it. And that 2 tells me that I'm going to look through all of my numbers that are primes now, all of my ending factors, and I'm going to group them in groups of 2 because this is a square root. So they have to match. So I have 2 2's here, and I have 2 2's here. For each group that I make, I'm going to go ahead and take out one of those numbers. So in this case, for both of these 2's, I'm going to take out 1 2. For the next one, I'm going to take out the other 2. And if you have any numbers that are left, like this 5 here, that aren't grouped, it's going to stay underneath the radical. Now, when you have more than one number that you're taking out, or you have, let's say, more numbers underneath the radical, all you do is multiply them together. So on the outside, I have 2 times 2, which is 4. So 4 square root of 5 would be the solution for simplifying my radical. Let's try number 2. So I'm just going to kind of ignore this negative 3 on the outside, and I'll use it at the end. And I'm just going to work with my square root of 45. So two numbers that multiply to equal 45 would be 5 times 9. 5 is a prime, so I can't break it down. But 9 can be rewritten as 3 times 3. I'm going to go ahead and X out any numbers that aren't primes that I already broke down. And because it's a square root, I'm going to group in groups of 2. So for each group, I take out one of those numbers. And any numbers that are left over that were not grouped will stay underneath the radical. Now, because this question had an extra number outside, I'm just going to continue to bring it down. And you're just going to multiply everything together. So because I have the negative 3 in front, negative 3 times 3 is negative 9. And then I'm going to bring my square root of 5. And that would be my solution for simplifying the radical negative 3 square root of 45. This should seem familiar. The last thing is rationalizing the denominator. I'm probably not going to go through all of these, but rationalizing the denominator means that you no longer want to write the answer with a radical in the denominator. So you know how one of the tips that I tell you is to use your calculator the least amount as possible. And these are the types of problems where if you use your calculator, it's not going to give you the right answer. You have to know how to do the math behind it. So this question is the same as square root of 2 over square root of 3. So even though they only have one radical there, that radical is actually belonging to the numerator and the denominator. The goal for rationalizing the denominator is that you're going to get rid of the radical in the bottom. And the way that you do that is you multiply by that square root of 3, top and bottom. Now, why did I pick square root of 3? Because that's the number that's in the denominator. And now that I've done that, this becomes square root of 6 on top, because 2 times 3 is 6, and this becomes square root of 9 on the bottom. I can simplify this more. I can't do anything with square root of 6, but square root of 9 is 3. And now you will notice I no longer have a radical in the denominator. And that's the whole point. Rationalize the denominator gets rid of the radical in the bottom. For this one, this is the same as square root of 5 over square root of 12. So if I wanted to, I could go ahead and do a factor tree really quickly for 12. And I'm going to notice that I already have a group that I could take out. So 12 could be rewritten as 2 square root of 3. So really, the only radical I have in the bottom now is square root of 3. And so that's what I need to get rid of. So the 2 is already outside of the radical. I don't need to pay attention to that. I only need to get rid of the radical on the bottom. So whatever I do to the bottom, I do to the top. 5 times 3 is square root of 15 since they're both under the radical. And in the bottom, this will become 2 times square root of 9. And as we just said in the last problem, square root of 9 is 3. And I'm just going to go through and I'm going to continue multiplying that till I get my answer of square root of 15 over 6. For number 6, let's go ahead and look at 18. I can do a factor tree for 18. That's going to be 9 times 2. This would be 3 times 3. I am able to make a group. So I'm going to get 4 square root of 3. There's a negative in front of this one. And 3 square root of 2. So again, the only radical in the bottom, I'm really ignoring the numerator when I'm doing this. So when I'm rationalizing the denominator, I'm only looking at the denominator. The only radical in the bottom is square root of 2. So again, I multiply by that, top and bottom. In the numerator, I'm just going to bring that negative 4 over. And since 3 and 2 are under the radical, 3 times 2 is 6. In the bottom, that's that 3. I'm just going to bring it right over. And 2 times 2 is going to give me square root of 4. I'm thinking of my numerator and denominator as two separate problems, kind of. And square root of 4 is going to give me 2. So I get negative 4 square root of 6 over 6. And I can actually reduce these whole numbers here. So the 4 and the 6 in the front, I could take a 2 out of both of those. So my answer is going to be negative 2 square root of 6 over 3. Remember again, the idea is to solve so that you no longer have a radical in the denominator. Now it's your turn.